Okay, so they're telling us that x is 3 tangent a. And so what we're going to do is we're going to take this 3 tangent a and we're going to plug it in right there for x and right there for x. Everywhere, the two places where we see x, we're going to plug in 3 tangent a. Why? Because it says up here x equals 3 tangent a. X is 3 tangent a. That means everywhere you see x, you can replace x with 3 tangent a because x is 3 tangent a. By the way, you don't really have to pay attention to this, although technically it is necessary. What are they saying here? Well, they're basically saying that angle A is between 0 and pi over 2. What's that? Well, 0 is here, pi over 2. Remember the unit circle? It's the first quadrant. They're basically telling us angle A is somewhere in the first quadrant. It's between 0 and pi over 2. Now, why are they saying that? Because remember the all students take calculus? All the trig functions are positive in the first quadrant. They're basically wanting all the answers to come out positive on this one, so we don't have to worry about negative signs. Now, don't even worry about it. Just know everything's coming out positive. So, all right, so everything's coming out positive. What do we do now? So I'm going to plug in that x. Remember when we plug formulas in, well, here, let me write it. 3 tangent a on the top, and then on the bottom, square root of. And now when we plug in, you put parentheses. So I'll put parentheses here and parentheses here. 3 tangent a squared plus 9. There we go. Okay, so what happened? I just plugged in to both those x spots 3 tangent a. Is that making sense so far? Okay, so now I'm going to simplify. 3 tangent a. On the bottom, square root of 3 tangent a squared. What happens? Well, you're going to square the 3 and square the tangent. You know 3 squared is 9. Tangent squared a plus 9. Can you tell my 9s from my a's? I hope. 9, 9. Here we go. Okay, is everybody seeing where we're at so far? Now, it's worth saying a couple of words at this point. Why do we put parentheses around things that we plug into formulas? Well, that way we're true to the meaning. What do I mean we're true to the meaning? Well, look right here. If I did not put parentheses around this guy, if I just wrote 3 tangent a squared with no parentheses, that would mean only the a is squared, not the 3. And that would not be right, would it? What do you mean that not be right? Why is it actually like wrong? Well, because what does it say right here? It says x is squared, which means all of x, right? All of x. And what is x? X is the whole 3 tangent a. So that means all of x, all of 3 tangent a needs to be squared. Well, how do you do that? You use parentheses. Do you see how the parentheses mean the whole thing is squared, not just the back part? That's why we use parentheses when we plug into things in math, because that way you're true to the original meaning. Okay. Now, another good question students have asked me in the past, they said, Mr. Why didn't you square the a also? You just squared the 3 and you squared the tangent, which is 9 tangent squared, but you didn't square the a. That's a great question. It's because the a is inside of the tangent. It's buried in there. What do you mean in there? Well, you know, tangent's a function. You put in things like 90 degrees or 30 degrees, right? That's the plug-in. Like I talk about toasters, that's the bread being put inside the toaster. Does that make sense? So, okay, yeah, but so why isn't it square? Well, because it's in there. So if you said, I'm going to paint the toaster, and you had a piece of bread in there, it doesn't mean you're going to paint the bread. The bread is hidden inside the toaster. You're just going to paint the outside of the toaster. Well, that's what's happening with the squaring. We're going to square the outside, the 3. And they say, well, you did the 3. Yeah, because he's outside. He's not buried inside the tangent. He's multiplying the front of the tangent. So yeah, he needs to be squared, and the tangent needs to be squared, but not the plug-in. You never square or do whatever power or function to something that's buried inside of a function. It's like it's inside of a toaster or something. You don't go inside. You just square the outside. That's why we do. That's all of math, not just sine, cosine, tangent. That's whenever you do a power on a function, you just do the outer function. You don't go to what's plugged into him, just like with a toaster. All right, so now getting back to this, what do we do now on this problem? Now, here comes a trick. When I say it's a trick, it's because it's probably not what you would naturally think. You're probably naturally thinking, well, look, I'm supposed to go to sine. It says right here, rewrite sines and cosines. I better take this tangent and make it sines and cosines. Isn't tangent sine over cosine? I better do that. No, don't do that now. We'll do that later. We'll do that later, but not right now. Why not? Well, because my main answer is experience. I can tell what's coming, and you will be able to also after you've done enough of these. Here's what I'm seeing. Here's what my eyeball is grabbing a hold of. I'm looking at this 9, and I'm looking at that 9 and going, oh, they have those in common. Okay, so what? Well, in mathematics, when we have something in common in two terms, those are terms because they're separated by a plus sign here, this plus sign. When you have two terms separated by a plus or a minus, doesn't matter, either one, and they have something in common, what you should do is factor it out. Let me show you what I mean by that. Square root's still there. You should put the 9 in the front, and you should put the common element in the front. And okay, great, I see it. But then how do you know what goes inside? What goes inside is whatever works. What do I mean, whatever works? I mean, there's going to be a plus sign here, and 9 times what and 9 times what will go back to 9 tangent squared a and plus 9. What will make that work? What could I put there that will make that work? Well, tangent squared, kind of run that room here. Tangent squared a plus 1. Does everybody see that? Let me pause there. I'm glad to talk about that more extensively. That's reverse distribution. You see that? Right? Because this 9 could distribute. 9 times tan squared, go back to 9 tan squared. 9 times 1, go back to 9, wouldn't it? Do you see why this is a 1? Because 9 times 1 will go back to 9. When this 9 distributes to those two things, we'll go right back to this, won't we? Do you see how that's the same thing? I've just undistributed it, reverse distributed it. We call that factoring. We factored out what they have in common. This is called a GCF. It's the greatest amount in common, greatest common factor. That's what that stands for. I'm not going to quiz you on all the names, but you might have heard them and might ring some bells for you. So when you see they have something in common, when they both have a 9, put it in the front, put parentheses, and reverse distribute. Put inside whatever works, whatever would multiply 9 times both of them, and it would go back. All right, well, feel free to bring up stuff you want to talk about. Okay. Now, I told you there were 2 most important theorems in this section. The most important one is sine squared plus cosine squared is 1. We don't have that right now. But the second most important one from the formula sheet is 1 plus tangent squared is secant squared. That one is on your formula sheet. Let me show you your formula sheet. And it's super important. It's the second most important right here. Oops, right here. So this is number 1, most important, and this is number 2. It'll come up a whole bunch in this section. 1 plus tangent squared is secant squared. So let's get back to it. Right here, there, do you see it? 1 plus tangent. It doesn't matter whether the 1 comes in the front or the back. That's 1 plus tangent squared. So when that has to jump off the page for you when you see that. You go, oh, there it is. So what do? 3, keep the top the same, 3 tangent A over the square root of 9. And then that 1 plus tangent squared of A, that becomes secant squared of A. You see what happened there, right? That whole, I replaced the tangent squared plus 1. The tangent squared and the 1 together became secant squared. and the 9 still sitting in the front of it. So that makes sense. That's what the formula says from your formula sheet right here. So 2 things are replaced by 1. 1 plus tangent squared is replaced by secant squared. 1 plus tangent squared replaced by secant squared. Now we're going to do the square root. Keep the top the same, 3 tangent A over. Square root of 9 is 3. Square root of secant squared is regular secant. The square root is gone. Did you see what happened there? You guys know that, right? Square root of 9 is 3. You know that. And the root vanishes, doesn't it? When you square root something, you do the root, square root of 9 is 3, and then the root is gone. He leaves the scene after he does his rooting job, right? And just like the square root of x squared is plain x, or the square root of secant squared is plain secant. Same thing, huh? See what happened on the bottom there? We square rooted the 9 to be 3, no more root. Square root of the secant squared to be plain secant, no more root. All right, we're getting close now. What can we do now? Well, now we can cancel these 3's. They're gone. So we have tangent over secant. I'm going to drop the a's. I don't need them. We know they're there. We'll put them on in the end. We're at tangent over secant. Now, finally, at the end, am I done? Well, no. They said write it in terms of sines and cosines. So now I will finally change to sines and cosines. I didn't want to do it before now. Why? Because I saw this 1 plus tangent squared thing coming, and I wanted to use that. You should have in your mind these 2 formulas and always be looking to use those in this section. I saw this 9 tangent squared plus 9. I thought, oh, if I take out the 9, I'll have 1 plus tangent squared, I'll be able to pop in the secant squared. So I wanted to do that first before I changed to sines and cosines. Now let's change to sines and cosines. What is tangent? Remember, tangent is sine over cosine. And remember, secant is 1 over cosine, and cosecant is 1 over sine, and cotangent is cosine sine. You have to use those. So tangent will be sine. I'm just going to write S and C, sine over cosine. And what's secant? 1 over cosine. We good there? And then you know what you do with a fraction on the bottom of fraction. You flip it up, huh? Because dividing is upside down multiplying. So this becomes sine over cosine times cosine over 1. It flips upside down. And then these cross cancel. It's sine over 1, which is just sine. That whole thing is just sine. Look at that. So the answer to this problem is just sine of x. Got to put the x back in. That is amazing how much that reduced, isn't it? And so there we go. Questions I can answer on that. Everybody see how that happened? So from the top, I took this x, plugged it in there, squared it. So it became 9 tangent squared, factored out the 9, reverse distributed the 9. And then used the magic formula. Tangent squared plus 1 is secant squared right here. Then I square rooted them. Square root of 9 is 3. Square root of secant squared secant. Canceled the 3's. Tangent over secant. That's sine over cosine. 1 over cosine. Flip it up. Cosines cancel. Sine. There it is.